All
So
right.
whatever the covalent molecules we have done, other than the giant structure, all are simple molecular structures. So what is the difference in between a simple molecular structure and a giant structure? The difference in between the simple molecular structure and giant structure is simple molecular structures always have fixed number of atoms. They will never change. Like one hydrogen molecule consists of two hydrogen atoms. One carbon dioxide molecule consists of one carbon and two oxygen atoms. One water consists of two hydrogen and one oxygen, and so on. So one molecule have got fixed number of atoms. But in case of the giant structures, the particles are infinite, the bonds are infinite. That makes something giant. All right. So the giant structures have got so many particles, so many bonds. So they are solid at room temperature and they have got very high melting and boiling point because so many bonds, infinite bonds are there. So they need lots of heat to be broken down. And, in case of the, giant covalent structure, or giant ionic or giant metallic, whatever the giant structures are there, they are solid with very high melting and boiling point. On the other hand, these simple covalent molecules have got a limited number of the particles. They have got limited number of the particles and they are usually liquids or gases. Like over here, the examples which are shown, other than water, rest of all of them are gases. The reason is in between the molecules, there are weak intramolecular forces of attraction. In between the molecules, there are weak intramolecular forces of attraction. So what is the meaning of weak intramolecular force of attraction? Now look at this picture. So in this picture, you can see in between the two water molecules. All right, these are the two water molecules. There is a very weak force of attraction. This force of attraction is so weak that it cannot bring the two water molecules close enough. So there are gaps between them. And this is the reason that it is a liquid at room temperature. It is a liquid at room temperature with a low melting and boiling point. Similarly, in between the hydrogen molecules, carbon dioxide molecules, the intramolecular force of attraction is so weak that they cannot come close together and they are either liquids or gases with low melting and boiling point. Achha. Other than this weak intramolecular force of attraction, the covalent bonds which are there in between hydrogen and oxygen, or in between two hydrogen molecules, or in between oxygen and carbon molecule, the covalent bonds are extremely very strong. If you heat water, the intramolecular force of attraction will break up. The water molecules go apart, liquid turn into gas. But heating cannot break up the hydrogen and oxygen covalent bond because they are extremely, extremely very strong. ठीक है हिबा? Got it? Did you understand, Hiba?
Yes, I got it. Sorry, my screen got stuck.
Okay. Now see this thing. Buckminster fullerene. What is Buckminster fullerene? It is one of the forms of carbon. We have seen the other two forms of carbon. What are the other two forms of carbon? Diamond and graphite. Diamond and graphite are the two other forms of carbon. But diamond and graphite are the giant covalent molecules because they have got unlimited number of the carbon particles, unlimited number of the bonds. But Buckminster fullerene is also made up of pure carbon atoms, but it is a simple molecular structure. Why? Because one molecule of fullerene has 60 carbon atoms. That's why we call it C60 fullerene. We call it C60 fullerene because one molecule have got 60 carbon atoms. All right. So remember this thing that there are three allotropic forms of carbon. Allotropic. We call it allotropic. There are three allotropic forms of carbon: diamond, graphite, and fullerene. So diamond and graphite are the giant structures because they have got unlimited number of the particles, unlimited number of the bonds, very high melting and boiling point. But Fullerene is also a form of carbon, but it has got only 60 carbon atoms in one molecule, low melting and boiling point, because in between the two fullerene molecules, there is a weak intramolecular force of attraction, which easily break up upon heating. So how is the structure of fullerene? Is just like a football. You can see the structure is just like a football. So these are the properties of fullerene, and so we can say these are the properties of all the they are simple molecules. Like they have low melting and boiling point because of the weak intramolecular forces. They are poor conductors. They are usually liquids and gases, etc., etc. So simple molecular substances, small molecules with weak intramolecular forces of attraction, but they have inside them strong covalent bonds. But intramolecular forces in between the molecules is weak. Acha. The same concept is here, that when you boil water, it turns into steam, but why it does not break up into hydrogen and oxygen? When you start heating water, the kinetic energy of the water molecules increase and they start moving faster. The intramolecular force of attraction between the water molecules break up. They go apart and they turn into steam, but the strong covalent bond between hydrogen and oxygen does not break. Got it, Hiba?
Yep.
Another thing, why water is a polar molecule? What is the meaning of polar? Having poles. What poles? Positive and negative poles. We are saying that water is a covalent molecule and sharing of electron is taking place. The charge should not appear. Positive and negative charge should not appear, but there is a slight contradiction over here. What is a contradiction? On the water molecule, we are seeing slight positive and slight negative charges. And so we can say that water is a polar molecule. Now, what is the reason behind it? The reason behind the polarity of water, why being a covalent compound, it has got slight positive and negative charge. Because of the unequal size of the particles, like oxygen has got how many protons inside? Oxygen has got 8 protons inside. Okay, oxygen's nucleus has got 8 protons, 8 positively charged particles. Whereas hydrogen has only 1 proton, 1 positively charged particle. So all the electrons naturally will be attracted to the side of the oxygen, because oxygen has more number of protons, more number of the positively charged particles. So it will try to attract all the electrons towards its side. So all the electrons are slightly tilted to the side of oxygen. That's why when the negatively charged particles are tilted toward the side of oxygen, it will get a slight negative charge. This is the sign of partial or slight. Whereas when the electrons of hydrogen are also trying to be tilted to that side, the side of hydrogen will become slight positive. The side of hydrogen becomes slight positive, like this. Similarly, if you will see this water molecule, this oxygen will get a slight negative charge because all the electrons are attracted to this side. And this side will get slight positive charge, not complete positive and negative, because complete gain and loss of electron is not taking place. As a result, the slight positive and slight negative slightly attract each other. So this slight attraction between slight positive and negative charges is the weak intramolecular force of attraction. And water, for that reason, has become a polar molecule. What is the meaning of polar molecule? It has got slight positive and negative charges. It has got slight positive and negative charges. All the electrons will be attracted to the side of oxygen because oxygen has got large number of protons. Got it, Hiba? Did you understand this idea?
Yes.
Is it difficult?
No, it's okay so far.
Okay, so you have to see the recording later. Now you see this is hydrogen chloride molecule. Hydrogen chloride is a gas, and hydrogen chloride has also slight positive and negative charge. How? Chlorine has got 17 protons and hydrogen has got 1 proton. Similarly, this chlorine has got 17 protons and hydrogen has 1 proton. So naturally, all the electrons are more attracted to the side of chlorine. So the side of chlorine is slight negative. The site of hydrogen is slight positive because it is showing a tendency to send the electron to that site. So in between slight negative and slight positive, a weak force of attraction is created, which is called intramolecular force of attraction. So hydrogen chloride is another example of the polar molecule. Acha. So we have finished this. Covalent bonding, polar molecules, and all those things. Now I am starting metallic bonding. Let's finish metallic bonding today, and then the homework I will give you the exercise to do. You will do the exercise at home. You will give more time to your self studies. Hey? Achha. Now I'm going to the metallic bonding. Metallic bonding is easy, small, not that big. So metallic bonding. So what is metallic bonding? So it is taking place within the same metal. It is an electrostatic force of attraction, which is taking place within the same metal, and it is holding the particles of metals close together, tightly packed together. How? Now see. Suppose we are talking about iron. Okay, suppose this is iron. This is iron. So in case of iron, iron is a very hard solid with very high melting and boiling point. With very high melting and boiling point. So the particles of irons are tightly packed together. So the electrons which are there in the last shell, all right, the electrons which are there in the last shell, they are so far away from the nucleus that they are very much weakly attracted by the protons. They are so far away from the nucleus that they are weakly attracted by the protons. As a result, they can no longer remain in their shell and they are given out. So these red color particles are the electrons which are given out by each atom. So as soon as the electrons are given out, each atom will get a positive charge over it because loss of electron gives a positive charge. Now see, the electrons which are given out, they are not still at one place. Rather, they keep on moving around the whole structure. And the electrons are the negatively charged particles. The cations are the positively charged particle. So in between them, a very strong electrostatic force of attraction is created, which is holding the cations very much close together, tightly packed together. This electrostatic force of attraction is a metallic bond, and this particular structure is a giant metallic lattice. Giant metallic lattice. So what is a giant metallic lattice? Even if it is a small stapler pin, that small stapler pin is the giant metallic lattice. Why it is a giant metallic lattice? Because it consists of unlimited number of the particles, cations, surrounded by the cloud of free moving electrons. These free moving electrons are also called as delocalized electrons. What is the meaning of delocalized? They have lost their location. They have lost their location. That was structure of metal, lattice of positive metal ions. What is the meaning of lattice? Lattice is any such structure which has got, nice arrangement of the particles. So lattice of the positively charged particles are nicely arranged, surrounded by the delocalized free moving electrons and held together by a strong metallic bond. What is a strong metallic bond? The attraction in between the free moving electrons and the positively charged particles. Delocalized electrons. Electrons from the outer shells that are free to move throughout the metal. And this makes metal a good conductor of heat and electricity. Why? Because the free moving electrons acting as a medium to conduct electricity. Then there are some other properties like metals are malleable and ductile. Now understand here. What is the meaning of malleable? Metals can be bent easily. What is the meaning of ductile? They can be stretched into thin wires. So when you are hammering a metal, it will not shatter, rather it will bend. The reason is that all the positively charged particles have the tendency to repel each other. Because positive cannot stay together, but here they are compelled to stay together because of the free moving electron clouds roaming around them, not letting them go anywhere. But under stress, they will get chance and they will roll over each other. So this regular arrangement will be distorted and they will become jumbled up. So when they become jumbled up, you will see a dent over it. You will see as if they have bent. Actually, the bending is because of the jumbling up of the cations. When you are pulling the metal, since the cations have a tendency to repel each other, they can easily, this layer will slide in this direction, this layer will slide in this direction. So they will be pulled into thin wires easily. So that is called ductility, malleability and ductility. Next. Conductivity, malleability, ductility, shiny, sonorous, etc., etc. Now, now see. Suppose we are talking about the metals of group number 1. So in group number 1, there is 1 electron in the last shell. All right. In group number 1, all the atoms in group number 1, all the atoms have got 1 electron in the last shell. So that 1 electron is far away from the nucleus, so they will be given out. So this 1 electron has come out, and each atom will get a +1 charge. Each atom will get a +1 charge. Now, the electrostatic force of attraction or the metallic bonding in group number 1 is in between +1 and -1 charges. Why +1 and -1 charges? +1 is 1 cation and -1 is 1 electron. Similarly, if you will see group number 2, if we talk about group number 2, in group number 2, all the atoms have got 2 electrons in the last shell. So these 2 electrons are far away from the nucleus. So these 2 electrons will be given out. These 2 electrons will be given out. And each atom will get a +2 charge. All right. Each atom will get a +2 charge. So what is the electrostatic force of attraction? It is in between +2 and -2 charges. And in case of group number 3, it will become +3 and -3. Now you can understand the difference. The weakest metallic bond, the weakest electrostatic force of attraction is in case of group number 1. The weakest electrostatic force of attraction is in group number 1. That's why the group number 1 elements have got low melting and boiling point, low density, float on the surface of water, and fragile. But at the same time, all group number 1, 2, and 3 elements are good conductor because they have got cloud of free moving electron. They have got cloud of free moving electron. In case of group number 2, the electrostatic force of attraction of the metallic bond is in between +2 and -2 charges. So the metal has become, the bond has become double stronger. So the melting and boiling point will also become increased. Density will increase. And so is group number 3. Aluminium is in group number 3. So the electrostatic force of attraction is in between +3 and -3 charges, which is huge. That's why the melting point of aluminium is thousands of degrees. And it is very hard, very tough. And all of them have got the common property, malleability, ductility, conductivity. They all are malleable, ductile, and are good conductors. Clear, Hiba?
Yes, miss.
So I have given all the slides to you already. All the slides are there. Now you take out your textbook, chemistry. We have finished this entire chapter of bonding.
Okay.
So metallic bonding, ionic bonding, covalent bonding, all the sort of bondings we have finished. Page number 96 and 97 is your homework. You will do it at home. And right now we are doing page number 100. We are doing page number 100. There are only 3 questions.
Which
if you
page
can
was
do them,
homework?
96 and 97. 96 and 97. And we are doing page number 100 now. There are only 3 questions. I want you to do and keep on showing me right now one by one as long as we have time. I will
All
keep
the
on
questions
checking.
in 96 and 97, right?
All the questions on page number 96 and 97. And start page number 100 right now.